Another method to solve systems of equations is by elimination. Generally speaking, most students like the elimination method the best. My thoughts on it are because it's the last one taught. But either way, your preference, your choice. So with elimination, let's say for instance that I have x minus 2y equals 1, x plus 1y equals 4. Now, if you've already watched the substitution video, you know this is the same exact example. You already know the answer, but you don't know the process. Okay? So what you're going to do, you are actually going to subtract your two equations. Your goal is to eliminate a variable. So in that case, most of the time, this is how I suggest it, is to get the coefficient in front of the x's to be the exact same. Now, with that being said, currently, in this case, my coefficients are the same. I can actually just go ahead and subtract. So 1x minus 1x gives me 0x, so I don't even need to list it. Negative 2y minus 1y. Key is always go out to this negative here. A lot of people will just see the plus sign and think, oh, negative 2 plus 1. It doesn't work that way. So negative 2y minus 1y gives me negative 3y. 1 minus 4 gives me negative 3. Therefore, y equals negative 1. In order to solve for x, then, you take that value that you found for y and plug it back into one of your equations. It doesn't matter whether it's the first one or the second one, you will get the same answer. So 1x minus 2 times negative 1 equals 1. That's going to be an x plus 2 equals 1. X, therefore, equals negative 1. Now, if you notice here, something didn't work out properly. That's because Mrs. Fish is goofy, and negative 3 divided by negative 3 is a positive 1. Sorry, my fault. It's good to know that your teacher is human as well. So x, therefore, equals 3. Now, you might be asking yourself, what happens if the coefficients aren't the same? Then you multiply. So for instance, let's say that I've got 3x minus 4y equals 1 and 5x plus 2y equals 45. Now, if I'm looking at this, I can see that my x's don't have the same coefficient, but I can multiply all of my top numbers in that first equation by 5. I can multiply all of the bottom numbers by 3 in order to get the coefficients in front of the x to be the same. So I've got 15x minus 20y equals 5. On the bottom, I've got 15x plus 6y equals 135. Now, looking at this, I actually have my x values coefficients to be this exact same, in which I can now subtract. We know 15x minus 15x gives me 0x, so I'm not going to write it down. Negative 20y minus 6 gives me negative 26y, and then I'm going to get a negative 130. I'm going to divide that by negative 26. Y is then going to equal 5. Now, you need to plug it back in. You have 4 options that you can plug in. I would do it in one of the original ones just because generally those are smaller numbers to work with and it's a little bit easier. So I'm going to go with the first one. I've got 3x minus 4 times 5 equals 1. 3x minus 20 equals 1. 3x equals 21. X therefore equals 7. Now, there will be times when you could potentially have a no solution or a infinitely many solutions. Similar to what happened with substitution, this right here, that's going to determine whether it's a no solution or a infinitely many solutions. What will happen is both the x and the y variables will eliminate. And it's either 0 equals 0 or 0 equals like 3. If it's 0 equals 0, that's always true, so it's infinite. But if it's 0 equals, say, 3, that's never true, so that would be a no solution. So this is just another way to solve systems of equations. So far, we've just dealt with equations of lines in 2 variables. We will be looking at 3 variable situations, which can be tricky, but we can make it.